All right, dividing. We're going to start off by dividing by unit fractions with a visual. So on the very top of the page, we have a worked out example. So problem number 1 is worked out for us. It's taking the whole number 2. Notice that we have 2 represented with complete rectangles at the top. So we have 2 wholes, and we're dividing by 1/6. So we're essentially taking each of those whole numbers and cutting it into 6 pieces. So I have 1, 2, 3, 4, 5, 6 pieces below the first whole, another 6 pieces below the second whole. This problem, 2 divided by 1/6, is essentially the same thing as asking the question, how many 1/6 fractions are there within 2 wholes? Oh, my dog is tearing up paper. Hold on. Stop it! That excuse, my dog ate my homework, I believe it more than ever now. All right, back to work. So, all we need to do to finish this off is find out, by counting, how many 1/6 are there in 2 wholes. Well, there's 6 from the first one, 6 more from the second one, so that's a total of 12. So our answer is 12. 2 divided by 1/6 is 12, meaning we can fit the fraction 1/6 into 2 wholes 12 times. So we'll repeat this for the following problems where you have to draw the partitions yourself. So let's try one more for good measure. 6 divided by 1/2. So we represent 6 with 6 full rectangles. Each one of those we're going to cut into 1/2 slices. So each whole I need to cut into halves. So we have 1/2 here, I have another 1/2 here. And I'll do that for each of the wholes. Oops, that one's not close to the middle. Let's fix that. And this is essentially like asking the same question, how many 1/2s are there inside of 6 wholes? So we have 2, 4, 6, 8, 10, 12. So there's a total of 12 here. Now something that's kind of interesting, and I want to draw your attention to this, 2 divided by 1/6, there's a connection here by the whole number and the denominator of the fraction. 2 times 6 is 12. Look at this next problem. We had another 6 and then 2 in the denominator. 6 times 2. So really, we're multiplying the whole number times the denominator here. And that's because we're doing whole number divided by a unit fraction. Another way to explain why the relationship is happening, for each whole number, we cut the whole number into the number of pieces that matches our denominator. So in the first problem, we cut the first whole into 6 pieces. 1, 2, 3, 4, 5, 6 pieces here. And we did that again for the second whole, so it's almost like counting 6 twice. So that's why we can explain that we are multiplying these numbers. You might remember that there's a shortcut for dividing fractions, so if you used that shortcut, 2 divided by 1/6 would become 2 times 6 over 1, which would be 12 over 1, or 12, and that's fine. I'm glad that you remember that if you do. However, make sure that when you're trying these visuals that you can understand how that relates back to the visual that you're being asked to use. When it comes time to teach this to children, they're not going to have that shortcut memorized. You will have to build that for them. So these visuals help build that. Dividing fractions using a number line is another visual that we can use. So we're again looking at a whole number divided by a unit fraction, and this first problem is worked out for us. So we start by representing the whole number on a number line. So we start off with 0 all the way up to 3. And then each of our wholes, so from 0 to 1, for example, that's a whole, we need to divide it into fractions with the same denominator as 1/6. So we're going to cut this into 6 pieces. And we'll do that again for the whole number between 1 and 2. And again between 2 and 3. And this is essentially the same question as how many times does the fraction 1/6 fit into the whole number 3? Well, we can count them by going over the little green humps. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So our answer would be 18. And no coincidence, the whole number times the denominator is equal to 18 as well. And that's because we're adding 6 from the first whole number, a 6 again from the second whole number, and a 6 again from the third whole number. 6 plus 6 plus 6, that's the same thing as 3 times 6, or 18. Let's do one more again for good measure. So we'll do problem number 2. We have the number 7 represented on our number line. It goes all the way up to 7. We can stop here. Technically, it does go up to 8, but that's okay to have a little bit extra. You just don't want to fall short. So 0 to 7 on our number line. Now we're going to divide it into thirds. So every whole number is cut into 3 pieces. And it's already done for us, which is pretty nice. But after we have cut all of these little tally marks on our number line, we need to count how many there are. We could do this one by one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we know our answer is 21. Or we could say, hey, did you notice that we were adding 3 pieces from this first one, another 3, another 3, another 3, another 3, another 3, another 3. We really added 3 7 times, which gave us 21. So if you struggled with dividing fractions before, maybe these models are helping to make clear why those shortcuts exist. Although I'll admit, sometimes I hear students say these make it more confusing at first, but the more practice you get with them, it will help to clarify why things work the way they do. Okay, we're going to step this up a little bit. Now we're dividing a whole number by a not unit fraction. Notice the numerator is a 4 here, so we're not using unit fractions, which can make this a little more difficult. So let me explain how this worked out example goes. We start off with 0 to 4 on our number line, so 0 all the way up to 4 on our number line. And we know that there's whole numbers in between there, so we have 1, 2, and 3 are already drawn up for us. And conveniently, the number line is already cut into fractions with a denominator 5. So from 0 to 1, there should be 5 pieces. There's 1, 2, 3, 4, 5. Perfect. And it continues all the way down the number line to 4. So it's already divided up for us, which is nice. And notice that the fractions, a few of them anyways, are identified for us on the number line. So that's kind of nice. Now we're asking, we want to translate this into the question, right? So this question would say, how many times does this fraction, 4/5, fit into the whole number 4? So we're going to look at 4/5 on the number line. 4/5 is here. So we're asking, how many times can this space fit into the number line until we land on 4? And so we're using an arc to represent a group of 4/5. Here's our second one, here's our third one, here's our fourth one, here's our fifth one. We were able to fit that fraction in a total of 5 times, so our answer is 5. Now I want to make a connection back to the shortcuts that you've learned in the past. 4 divided by 4/5 would become 4 times 5/4. And the reason why, if you remember, is that we multiply the whole number by the denominator to count the number of pieces we have. There are 20 pieces. And notice that that 20 shows up right here. If we took the number 4 and divided it into 1/5, it would look like 20 over 5 total pieces here. But then we're saying, no, we don't want 1/5, we want 4/5. So we're going to take all 20 of those pieces and group them into 4, which if you take those 20 pieces and group them into 4, we'll see that we have a total of 5 groups. And 20 divided by 4 comes out to be 5. All right, let's do one more, number 2. So 6 divided by 3/6. So we know that we have 0 through 6 on our number line. All of the whole numbers are already cut into 6 pieces. We can double check that. Awesome, there's 6 pieces there. And now we're just going to count up looking at 3/6 at a time. So we're going to jump from 0 up to 3/6, do another 3/6, do another 3/6, another one, and another one, and another one. We're just making sure that we have 3 of those little pieces in each of these groups that we're making. Until we get to the end, then we go back and count them. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There was a total of 12 here, so our answer would be 12. All right, try the rest of those. Hopefully they go smoothly for you. On the next page, we are looking at using horizontal and vertical cuts similar to what we did in the past on the addition and subtraction worksheet. But it's a slightly different process, so let me walk you through it. If we would like to take a fraction and divide it by a whole number, this is different than what we've done before. All of the problems we did before, the whole number was the first number. So now we've reversed it. Fraction first, then divide by whole number. So the first thing we do is start with a complete square and then cut it to represent that fraction, 1/3. So we cut it into 3 horizontal strips, shade in one of them to represent 1/3. Next, we're going to split that into 4. So if we're taking 1/3 and dividing it into 4 pieces, then we need to take that 1/3 and cut it into 4 pieces. 1, 2, 3, 4 pieces in that top row. And then we want to figure out how to describe this as parts of a whole. So right now we can see there's 4 pieces, but each one of those pieces, what size is it? What's the denominator of the fraction for this piece? To figure that out, we would just extend the cuts that we made, the vertical cuts, count the total number of squares inside of the big square. So we have 4, 8, 12. This square has a total of 12 partitions. And notice that 4 of those are shaded in, but one of those 4 is what happens when you take 1/3 and you cut it into, sorry, I erased the wrong piece here. Let's clean that up. When you take the 1/3 and cut it into 4 pieces, you're only going to count one of those as the answer for your division problem. So imagine that you have this blue rectangle and you want to divide it, maybe it's a chocolate bar. So yeah, let's put this into context. Let's say you bought a chocolate bar from the grocery store, but you're a lot like me and you can't leave the store without eating some of it. So alone, you eat 2/3 of the chocolate bar, which means there's only 1/3 left. You go home and you have friends at home who are like, I need some of that chocolate too. So you want to split it for your 4 friends. They each want a piece. So you say, okay, my first friend gets this piece, my second friend gets this piece, my third friend gets this piece, my fourth friend gets this piece. So that one square represents how big a piece each of your friends got, which would be 1/12. Now maybe you remember how to do this using the shortcuts. So that problem would look like 1/3 divided by 4, which turns into 1/3 times 1/4. And then you multiply across the top to get 1, multiply across the bottom to get 12. So this visual is really just trying to help understand what's happening in the shortcuts. Of course, you're still going to use the shortcuts, but now maybe they make more sense as to where they came from. Oh, let's do another example here. So let's do, I'm not going to do this first one because cutting into 7 slices is going to take quite a bit of time for me to demonstrate. Instead, let's do problem number, oh, I can't do 11. That's just like the example. Whatever, I'll do problem number 1. No fear, let's do it. So first things first, we want to represent the fraction. So we start off with a complete square that we need to cut into 4 pieces. I know I'm cutting it into 4 because my denominator is 4. The fraction is 1/4, so I'll shade in 1 of those. And then I need to cut this into 7 pieces. So I've got 1, 2, 3, 4, 5, 6, 7. So there's 7 pieces. One of those pieces is my answer. So now I want to talk about what size that piece was. I don't know why the blue keeps coming forward. Do you see that? There we go. That red square in the top left corner, that's our answer. So we need to talk about how big that is. There are a total of 28 pieces in this square. You can count them if you want. And one of those is the answer. So 1 out of 28 would be our answer. Let's do one more. We have 1/3 divided by 6. So I'm going to start off by representing 1/3. And then I'm going to cut that 1/3 into 6 pieces. And then I'm going to extend each of those cuts all the way down to the bottom so that I can figure out what the denominator of my fraction will be. If I count how many pieces there are, there's 6, 12, 18 pieces total. And one of those 18 pieces is my answer, so 1/18 would be the answer. All right. Back to our number line. Whoopsies. This time we have a fraction divided by a whole number. We're going to show you how that looks on a number line. First thing we'll do is represent our fraction 1/4 on a number line. So we have 0 all the way up to 1/4. Now you see more of the number line, and the reason for that is because we're trying to make sure that we represent 1/4 appropriately. So 1/4 is really somewhere between 0 and 1. So if you put on your number line 0 to 1, and then you cut it into 4 slices, now you're able to see 1/4. And then from 0 to 1/4, we want to cut that into 2 pieces, and that's what we're doing with this marker right here. So we have 1, 2, and one of those pieces would be our answer. The size of that piece is our answer, and we need to figure out what the denominator of that would be. In order to figure out that denominator, we need to know how many of those pieces would make up an entire whole. So how many of those would we need to get all the way to the end? Well, we would need 1, 2, 3, 4, 5, 6, 7, 8. So that little piece that I'm saying is our answer, that's 1 out of the 8 pieces that you would need to make a whole. So 1 out of 8. Let's do one more for good measure. 1/4 divided by 6. So let's start off by drawing a number line 0 to 1. Oops, 0 to 1. We'll cut that into 4 pieces. 1, 2, 3. We have 4 pieces here from 0 to 1. And it's saying take one of those fourths. So from 0 to 1/4, we want to cut that into 6 pieces. 1, 2, 3, 4, 5, 6 pieces. And we actually need to do that for all of them. 1, 2, 3, 4, 5, 6 pieces. 1, 2, 3, 4, 5, 6 pieces. 1, 2, 3, 4, 5, 6 pieces. And we can count how many pieces there are total. There are 6 here, 6 here, 6 here, 6 here, which means there's a total of 24 pieces between 0 and 1. If we are taking 1/4 and dividing it into 6 pieces, then one of those pieces would be our answer, so our answer should be 1/24. Now, the good news is you know how to calculate these with the shortcut, you know how to calculate these with a calculator, so I want you to work on trying to make the model match what you know the answer is supposed to be. And it's going to be frustrating at times to try and struggle with these models when you already know what the answer is. But the truth is, understanding how to represent the math is more powerful than just telling someone that you know what the answer is. So we really want to make sure that we are able to represent these concepts in a clear and coherent way. This next page is just using the shortcut. So once you've mastered the models, you are graduated on to the shortcut, so go for it. And then we start to get into the non-unit fraction division. So notice that we're gradually increasing the heat on each one of these problems until we're at max temperature, right? So we're getting a little warmer here. 2/3. This is more difficult than the last one because 2/3 is not a unit fraction. But we're going to do this pretty similar to how we did the unit fraction, so bear with me. We're looking at 2/3 divided by 5. Now, you might make a connection with how this picture is already drawn, saying, all right, from 0 to 2/3, we cut it into 5 pieces. But be careful looking at it that way because although that is what's happening, we took 0 to 2/3 and we cut it into 5 pieces, you might ask yourself, well, how big is this piece then? We don't know that. That answer is not immediately obvious to us. So in order to do this, we're going to have to do some more cuts on our number line. So we're going to start off by saying 0 to 1 on our number line. Cut that into thirds. That way we can represent 2/3. So that first fraction in our division problem, we want to make sure that we can represent that. Now from here, I want you to ignore the green line for a minute because it actually makes things slightly more complicated for us at the moment. Let's think about just this piece of the number line, 0 to 1/3. And I want to cut that into 5 pieces. 1, 2, 3, 4, 5. I'll do that again from 1/3 to 2/3. 1, 2, 3, 4, 5. So I'm taking my 2/3 and I'm focusing in on each of the 1/3, just like we did before. So from 0 to 1/3, I cut that into 5 pieces. From 1/3 to 2/3, I cut that into 5 pieces. Now, you could look at this as like we are doubling the problem 1/3 divided by 5, which is exactly what we're doing. We took 1/3, cut it into 5. We also did 1/3 over here and cut it into 5. So with the models that we did before, we said one of those pieces would be our answer, but we did the problem kind of twice. So it's really like 2 of those pieces would be our answer. And that's where if you stacked those 2 red pieces together, I think let me try and move it. OneNote has some pretty cool features. Let me see if I can, nope, try it again. Slide that bad boy right there. So remember when we said, oh, we don't know what that number is. How big is that piece? It's 2 of those red pieces. So we just need to figure out how big one of those red pieces is. Well, the red piece came from 5 pieces between here, 5 pieces between here. We would need to do another 5 pieces. 1, 2, 3, 4, 5 pieces here. That's a total of 15 cuts between 0 and 1, which means one of those red rectangles is 1/15. We have 2 of them, so our final answer would be 2/15. So that piece that we were saying, oh man, we wish we knew how big that was, that piece is 2/15. All right, I understand that that felt like a lot, so let's do another one. I need to, I'm not going to clean it up. Let's leave it there. I'll write in green so that it's a little bit of a contrast. 2/4 divided by 4. You could look at this as doing 1/4 divided by 4 twice. So we start on a number line 0 to 1, cut that into fourths. We have 1, 2, 3, 4 pieces between 0 and 1. Then we're going to cut each one of the 1/4 into 4 pieces. So 1, 2, 3, 4 pieces there. If we were just looking at 1/4 divided by 4, our answer would be one of these pieces. But we're not looking at just one of those, we're looking at 2 of those. So let's repeat that argument over here. Cut from 1/4 to 2/4, we're going to cut that into 4 pieces. And again, one of those bricks would be part of our final answer. And then I'm going to move that second brick, slide it up right here, so that we can see our actual answer will be 2 of those bricks. And if we tried to count up with arcs, we have 1, 2, 3, 4. We're able to make 4 groups within 2/4 of this same size. So again, we just need to figure out how big is that piece. How big is that 2 groups together? So let's count it out. We have divided up our number line into 4 pieces between every fraction. Which means we have 4, 4, 4, 4, or 4 times 4, there's a total of 16. We shaded in 2, the red ones, 2 out of 16, so our answer would be 2 out of 16. This one's a little tricky, so please let me know if you have questions on it. I'd be happy to help. But give it a shot. Struggle with it for a little bit, maybe no longer than an hour. Don't spend more than an hour trying to figure this out. If you feel super confused after an hour of trying to digest this, please let me know. I don't want you to spend your whole weekend working on it. The next page is word problems. So you're going to try and do some word problems using any of the models that you've learned throughout the packet. And then, of course, unit fraction word problems. I'll admit that this page is probably easier than the one before it, so if you want to do those two out of order, I wouldn't blame you. All right, have fun with your division worksheet, and let me know if you have any questions.